Hi students, let us continue with the solution of the NEET transient material. So here there is a police car which is chasing a motorcyclist. Okay, the police car is traveling with velocity 22 meter per second and it produces horn of sound having frequency 176 hertz. This is the velocity of the sound. Velocity of sound is 330. There is a both are moving towards a stationary siren. This is stationary, so this velocity of this is 0, and the siren is emitting sound of frequency 165 hertz. Question is this: what should be the velocity of the motorcyclist so that he does not hear any beats? Now, why will he hear beats? For beats, you need two sound waves having slightly different frequencies. Then you hear the resultant sound will vary in intensity with a frequency f2 minus f1. The bigger frequency minus the smaller frequency, right? So one sound he will receive from the horn sound produced by the police, right? So let's say that sound has frequency f1. And the other sound is coming from the siren. Let's say that is having frequency f2. Will that f1 be same as 176 hertz? No, because there is relative motion between police and motorcyclist, right? So this f1 will be what? What is the formula? Actual frequency is 176, right? Velocity of sound v. Now, which is the observer and which is the source? This is the observer, which is going away. So away means frequency should decrease. So I should write minus VO, right? And this is approaching. This is source, which is approaching. So frequency should increase. So I should write minus. Denominator should be less, right? If the frequency has to increase because of the velocity of the source. So then minus 22. And this is basically your velocity of observer is your Vm, which we are supposed to find. Right? So this will give you F1. Okay, later we'll substitute the value. So we can substitute now also. So 330 minus Vm divided by 330 minus 22, which will be how much? 8. 330 minus 22, that will be 803. 308. Okay, into 176. That is your F1. Now F2 is the frequency of the sound heard by the motorcyclist from the siren. So this is your source. Actual frequency is what? 165. Okay, and V V VO, observer is moving towards the source, so frequency should increase, so plus Vm. This is at rest, so plus minus 0, source is at rest. So this will be your 330 plus Vm divided by 330 into 165. So basically what you have to do now next is equate these two. Why equate? Because they don't want any beats to be heard. This person doesn't want beats to be heard. So the difference of this frequency and this frequency should be 0. That means f1 should be equal to f2. Once you substitute, you can do the arithmetic to find Vm. Okay. Let's do the next question now. Assume that the Sun rotates about an axis through its center and perpendicular to the plane of rotation of Earth around the Sun. Okay, so assume that Sun rotates about an axis through its center, and that axis should be perpendicular to the plane of rotation of Earth around the Sun. So if this is your Sun and this is Earth, and that Earth is rotating around the Sun, this is the plane, the Sun should rotate around its axis passing through center, and that axis should be perpendicular to this plane they have mentioned. Okay. The appearance of the Sun from any point on the Earth. So let's say here this point, any point they told. So this is Earth. is shown So here the diagram is missing. Light belonging to a particular spectral line is received from the points A, B, C, and D on the edges of the sun are analyzed. Options are: light from all the 4 points have same wavelength, light from C has greater wavelength, then light from D, light from C has smaller wavelength, then light from D, light from A has greater wavelength, then light from D. So basically, right, what the question says is you have to mark 4 points. Okay, so here A, here B, here C, here D on the sun. So you have to visualize this. Okay, so let's say it's rotating this way. That means A is going this way, right? B is going this way. C is coming this way out, right? Out, and D is going this way. So you can see at point A and C, if you think this is Earth, then at this point its velocity is this, which means it is perpendicular to the line joining this point and this Earth, right? This here the velocity will be into the boat. So that velocity is perpendicular to this line. So there will be no relative motion along this line. So there will be no Doppler shift. So the wavelength of light from here will be same, will be unshifted. It will be neither more than the actual or less than the actual. Here same story, because here it is coming out. So it will be like this, perpendicular to this line. Whereas here, the back side here, it is going this way. So this is going away from this point. This is coming towards. That means the frequency of light coming from B will be less. It will be less because it is going away. And frequency of light coming from D will be more, which means wavelength of light seen from this point will be more than the wavelength of light seen from this point. So based on this, you can see which is the right option. So light from C. So here C and D they have mentioned. So basically these two may be C and D. Okay. Anyways, I hope you understood the concept, right? So this and this will be same. Here it will be, here it will be, frequency will be less than this, which means wavelength will be more. Here frequency will be more because it is coming towards the observer. So wavelength will be less. 49th question, let us see now. A train whistling at a constant frequency is moving towards a station at a constant speed v. So frequency is constant and speed of the train is also constant towards the station. Okay, so if this is your station, yeah, the train is coming with a constant speed v, emitting sound waves of constant frequency f. The train goes past a stationary observer on the train. So it's coming like this and then it goes past. Okay. So sound waves, see, sound will be coming this way, right? In all direction. But observer was here, so I showed this way. Similarly, here sound will be going in all direction. Observer is here, so I will show this way, right? Constant frequency. So they are asking the frequency of the sound heard by the observer is plotted as a function of time. You know that frequency of this heard by the observer is given by f v plus minus vo v plus minus vs. In this case, it is coming, source is coming towards, so frequency should increase. So this is minus. Observer is at rest, so this will be 0. Now speed of the train is, speed of sound is constant, speed of source which is train is also constant, this is also constant, this will be constant. Similarly in this case, when it is receding, this will be also constant, like double dash, let's say. It will be also constant, but this constant will be less than this constant because here it is coming to us, here it is going away. So we plot a graph of frequency f dash, which is heard. Then while coming, frequency will be constant but more, while receding it will be also constant but less, so less than this. Okay, so the graph will be, sorry, it cannot be, frequency cannot be negative, so the time should be here. So it should be more and it should be less, both positive path. So it should be constant. Okay, it cannot be option A, B, or D, because there the graph is changing, the graph is curved, whereas the frequency should be constant. Fine. Okay. So this completes the NEET section, which I have done almost. I've covered all the concepts starting from waves velocity in transverse stream, closed pipe, open pipe, standing waves, beats, yeah, then Doppler effect, in fact even speed of sound in terms of molar mass. So all concepts are covered. So if you revise these questions, it will be very helpful for you. Next I will be doing JE level questions. So for that you can wait 1 day or 2 days. Okay, thank you.